So we continue with the chapter sound, and now we are going to see about the representation of a wave. So a wave while propagating in a medium can be represented by following two graphs. One is the displacement time graph and the displacement distance graph. So first is the displacement time graph. So in the displacement time graph, you always have it this way, that the y-axis is the displacement. So this is the displacement, and over here is the time. So this is the time. Okay. So the particles, they are going to move this way. They move like this. Okay, they are going to move like this, where this becomes the amplitude, and from here to here, whatever is the time taken is your time taken t, which is over here up to here is the time taken t. So that this is nothing but the displacement time graph. Now the displacement time graph shows you, first thing is amplitude. The second thing it tells me is the time period. Okay, and if I know the time period, I can also find out the frequency. So the third thing is frequency, because I know that frequency, which is 1 upon t. So whatever is the time period I get over here, 1 upon that will give you the frequency. So the displacement time graph shows the variation of the displacement of the particles of the medium with time at a given position. So it is something like this के body हमने stopwatch चालू किया और body move होने का चालू हुआ, यानी it is like this, the body started moving from here ऐसे move होने का चालू हुआ, मैंने stopwatch चालू किया तो क्या हुआ, ये ऐसे गया, तो यानी क्या, the distance from the mean position is keeping on increasing, यहाँ पे maximum point आ गया. So that's why the distance keep on increasing, यहाँ पे maximum point आ गया. So this point is representing the point over here. Then what happens? It is coming back to the mean position. So it is reducing. At this point, it is coming to the center point. So again, it is reducing and coming to the center point. That means it has come back to the mean position. This is point 0. This is the zero displacement. This zero displacement. So this is point where it is coming back to normal. So it is coming back to the mean position. यहाँ से गया, वापिस इधर आ गया. अब क्या हुआ? It is going on this side. When it go to this side, so it is keeping, but in the opposite direction. So it is, we are taking it to the negative side. So it is going further. ये last point आ गया. यानी it goes further. ये last point आया. उसके बाद it is coming back to normal. So it is coming back to normal. So it is coming back to normal and coming back to the. So this is one wave from here to here and back. From here to here and here and back is one wave. So that is how we are showing this one wave. So the amplitude is the distance from here to here or from here to here. That is the amplitude. And the time taken for one complete movement is called as the time period. So that's the time period. It is called the displacement time graph. Sorry, when a wave displacement time graph shows the variation of the displacement of the particle of medium with time at given position when a wave propagates through the medium. It is called displacement time graph. The amplitude is represented by the letter A and the time period is represented by letter T. The amplitude of the wave is 2 centimeters and the time period is 4 seconds. So here we see that if this is given over here as 2, this over here is -2, this over here is, let's say 2 seconds. क्या दिया? 2 दिया. यहाँ पे 2 दिया है, ये 4 दिया है. That means 1, 2, 3, 4 से लिखा है. So this is 1, this is 2, this is 3, this is 4. So you know that the time period is 4 seconds. Okay, this is time period. So this is time. We already done that in seconds. So and this one is the displacement in meters. So accordingly you have the distance moved is 2 meters. So amplitude over here is A, which is equals to 2 meters, and the time period over here is complete is equals to 4 seconds. So this is 1 upon 4, which is 0.25 hertz or second raised to -1. So that is the displacement time graph. Now we see the displacement distance graph. So in the displacement distance graph, it will be quite identical this is the displacement in meters. Again, this is the mean position O, this is 2, this is minus 2. Over here is the distance. So instead of the time, it is a distance. Why the distance? Because we need to find out the wavelength. So now this is going to be the same way. It is going like this. It is going like this. So from here to here, so this is of course the amplitude. This is amplitude. Okay. Distance from here to here, this particular distance is called as the wavelength. So what you find out in case of a displacement time distance graph, so this is the displacement distance graph, and it tells me first is the amplitude. So it tells me the amplitude. The amplitude is equal to 2 meters. And here also we'll write over here is 1 and 2. So the second is wavelength. Wavelength is also 2 meters because this is 1 and this is 2. So this is 2 meters is the wavelength. So figure shows that the variation of the displacement of the particle of the medium in different positions with distance at the same time. For where here amplitude of the wave is shown in the letter A and the wavelength is shown by the letter lambda. For example, in the figure 7.4, amplitude is 2 centimeters and the wavelength is 2 meters. So here it was in centimeters and here in meters. So we'll need to change this as centimeters and this is in meters. Here also actually it is in centimeters and that is time in seconds. Now do you know, in a longitudinal wave, that is in figure 7.3 and 7.4, the displacement on positive y-axis shows the motion of the medium particle in the direction of propagation of the wave, while the displacement of y-axis shows the motion of the medium of the particle in the direction opposite to the propagation of the sound. We can see this thing. When I took it on this side, abhi sound is traveling on this direction. So when I put it on this side, I said it is going upwards like this. And when it came back and gone this way, it is going in the down. So upper part is the one which is moving in the direction of the sound, okay, wave, and the other opposite one, the down one, is the one which is in the opposite to the direction of the wave. If the particle medium vibrate normal to the direction of propagation of wave, the wave is called as transverse wave. So if the particles are moving like this, okay, perpendicular to the wave, agar ussa se, like the ripples of the if you take a stone and put it into and throw it inside a steady water, what happens? You will find some ripples over there. So that ripples what are formed are called as transverse waves. This kind of waves whatever we are formed are called as transverse waves. Sound wave produced in string are transverse waves. The string में या तो हम लोग ने वो elastic rubber band में जो किया था वो क्या था? Transverse wave. So the sound which is formed in the string or guitar के अंदर वगैरह जो है, या तो even in case of any stringed instruments, they are going to give you a transverse waves. Now we see the next part of the chapter, that is characteristics of sound. What do you mean by characteristics of sound? Any sound which you hear, you will be able to easily tell some features about that sound. Like for example, you can say, oh, it's too loud. Okay, that is one kind of a feeling, that okay, you feel that it is too loud. Okay, so that is one kind of feeling. Other thing is that, oh, she is too shrill, or it's high pitch. Okay, like for example, if some girl is screaming, so you can understand that screaming sound, it's very irritating, and that particular screaming sound is called as a shrill sound, or it's called as a high pitch sound. So yes, you can identify whether it's a sound which is going to be very screamy type, or whether it is going to be flat tone. So that will be about the pitch. So one thing was the loudness, second thing was the pitch. The third thing which is there is the one which is called as the quality, which is going to identify the sound which is produced by two different kind of instruments or people. Like for example, when you are going, when you are walking by, and if somebody just calls you out, you can easily identify that, oh, this was my friend so and so is calling me. Okay, you can identify that thing. it is not going to happen that you will just, if you are, it is very common kind of a sound to you, you can easily identify that, okay, this particular sound is of my mother, or this is from my friend so and so. So this you can easily identify. So the identification of the sound, see, everybody has just given out your name, but still you are able to identify that who called you. So that is because of the quality of the sound. So these are the three characteristics what you are going to study one by one in this particular part of the chapter. So characteristics of sound. A sound is characterized by its amplitude and frequency. Depending upon the amplitude and frequency of the sound wave, two sounds can be distinguished from one another by the following three different characteristics. First, loudness. Second is pitch or shrillness, or quality, that is, or timbre or waveform. So these are the three ones. Loudness. So, and we can see that all of them, all these characteristics are dependent on the type of waves and are dependent on the amplitude and frequency of the waves. So if the amplitude, now let's see how the amplitude is going to make the sound different, or how the frequency is going to make the sound different, and what is about the quality. So first thing, so what we have is the three things. So we'll first try to understand what is loudness. So the first characteristics of the sound is loudness. Loudness is the characteristic of sound by virtue of which a loud sound can be distinguished from a faint sound, both having the same frequency and same waveform. So it is something like this, that there are two waves. One wave which is like this. Okay, one is wave like this. Second wave over here is like this, that it is going to be this way. So you can see the time taken over here is the same. Okay, but here the amplitude is very small, whereas here the amplitude is quite high. Here the amplitude is so high. So both are having the same waveform, they have the same time period, so they have the same frequency, they have the same wavelength. So what is the wavelength? That is one length. One length over here is lambda. Over here also is the same thing, lambda. Even if I take the same thing for the displacement time graph, then this is the time period. This is also the time period. So you can see the time period, wavelength, the kind of is the same, but the amplitude over here is less and here it is more. This is a flat, or you can say a feeble sound, whereas this is a loud sound. So when the amplitude is higher, we say that it is a loud sound, whereas the frequency, the wavelength, the time period, they are going to remain the same. So loudness is the characteristics of the sound by virtue of which a loud sound can be distinct from a faint sound, both having the same frequency and same waveform. So the waveform is the same, the frequency also same. Okay, the shape of the wave is also the same, but only thing is that the amplitude is different. The loudness of the sound depends on the amplitude of vibration of the vibrating body producing the sound. Greater the amplitude of vibration, louder is the sound produced. So jitna jada amplitude, utna jada sound. So if I am having this thing, and if it is more and more, if it is more, the sound what is going to be produced will be definitely more. ये sound कम produce करेगा और ये ज़्यादा sound produce करेगा. So this because the amplitude is more. Similarly, when you take drum, a small drum is going to give you a sound, not a loud sound, but वो जो पूरा वो लोग दिखाते हैं ना कि villages में इतना बड़ा सा drum है और वो राजा महाराजा वो डूम 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 कर रहे हैं, तो वो क्या बड़ा इतना drum क्यों है? So the loudness of the sound is greater. Figure shows two waves A and B of same wavelength, the same frequency, and same waveform, but the amplitude of wave 1 is 2 meters while that of wave 2 is 4 meters, thus the amplitude of wave B is greater than wave of A, hence the sound B is louder than the sound A. So you can see the sound B is louder than sound A, or you can see over here this is much more prominently shown. ये इतना छोटा है whereas ये इतना बड़ा है, but the time taken is the same and the frequency is the same. For example, if they gently pluck the strings of the guitar or a sitar, or a soft sound is heard. But if you pluck the string hard, it gets displaced more from its rest position. That is, its amplitude of vibration increases, so the loud sound is heard. So guitar में हम लोग सिर्फ छोटा सा करेंगे तो टिंग टिंग करेंगे, पर ट्रैंग, automatically the sound will be louder. If you strike the drum gently, a faint sound is heard, but if the strike is hard, you hear a loud sound. If you gently strike a tuning fork on a rubber pad, you will hear the feeble or soft sound, but if you strike it hard on a rubber pad, a loud sound is heard. What is a tuning fork? A tuning fork is an apparatus like this, made up of steel. So it will be a apparatus like this, and this will be handle over here. So you are going to take this in your hand, and this part you are going to hammer on a rubber pad. So this will start vibrating. This will start vibrating, and the vibration of that thing is going to form a sound. You can hear a sound due to this vibrations. Similarly, if the key of the piano is hit harder or a pipe is blown harder, we put more energy in the vibrating system, due to which the amplitude of the vibration is increased and a loud sound is produced. So, anywhere, any particular place, wherever you find that if the energy input for the production of the sound is higher, then automatically the sound produced will be of higher amplitude. Accordingly, it will be a loud sound. So if you are hitting something harder, yeah, this was a loud sound. This is no feeble sound. This much feeble sound. So when I'm putting more efforts, okay, when I'm putting more amount of energy to it, automatically the sound which is going to be produced will be much louder as compared to which is just the normal ones. So the dependence of the loudness on the amplitude of the vibration can be demonstrated by the following activity. Producing a faint and sound on a drum. Take a drum, a pencil and a stick. First beat the drum gently with the pencil. You will hear a faint sound. The reason is that the membrane of the drum vibrates with small amplitude. Now beat the drum hard with the stick so that the membrane of the drum vibrates with a larger amplitude. You will note that it is loud sound. So quite an easy thing. अगर पेंसिल से थोड़ा थोड़ा करेंगे तो इतना ज़्यादा साउंड नहीं आएगा, और वही अगर स्टिक से धार 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 मारेंगे तो लाउड साउंड आएगा. सो दैट इज अबाउट द loudness. The next is, let us understand what are the factors which will affect the loudness of the sound. Now this is a very important part, that what are the things, what are the different factors which should be around it to have a loud sound. So if I want to hear a loud sound, or when I make a loud sound, what are the things which is going to help me to produce a loud sound? So the loudness of the sound depends on the following factors. First, on the amplitude of the wave. Of course, it is the amplitude of the wave. So more the amplitude, more will be the loudness. So when a body vibrates with greater amplitude, it sends forth a greater amount of energy, and hence the energy received by the eardrums is large, so the sound heard is louder. This is why this can be understood by the following activity. Take a drum, place a ping pong ball on the membrane of the drum, beat the membrane gently with the drumstick, a feeble sound is heard and the ball moves to a small height, showing that the amplitude of the vibration is small. Now beat the membrane harder with the drumstick. The drum produces a louder sound and the ball jumps higher, showing that the amplitude has increased. So it's a very simple experiment. You are taking a drum, you are taking a small ping pong ball, okay, table tennis ball, and then you are just hitting the drums with a very faint kind of pressure force. So अगर वो force ज़्यादा नहीं है, तो you can see the ping pong ball will just vibrate like this, like this, like this. पर अगर अपने जोरों से मारा तो पिंग पोंग बॉल भी धार 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 मारेगा. Plus the sound what will be heard will be more in case when you are hitting it. So depending upon what is the height to which the ping pong ball is going to rise up, you will find that the loudness also is increasing that way. So the the height to which the vibromal vibrates is going to give you an idea that how the energy which is given to the particular drum also keeps on increasing. So this way, the first thing is the amplitude of the vibrations are going to be the first kind of a factor affecting the loudness of the sound. The second is on the distance of the source of the sound. Simple है, अगर कोई मेरे बाजू में ड्रम बजाएगा तो ऑफ कोर्स इट इज गोइंग टू बी हियर, आई एम गोइंग टू लिटिल लाउडर. बट अगर वो कोई दूर सम 500-600 meters अगर दूर कोई बजा रहा है तो विल आई हियर अ लाउड साउंड? नो, आई एम नॉट गोइंग टू हियर अ लाउड साउंड ओवर देयर. सो if the source of the sound is near, you hear it louder. If it is far away, then it is going to be less amount of loudness. So this experiment over here, they also done experiment. एक टेबल पे ऊपर एक अलार्म क्लॉक रखा जो चालू है. If it is near your ears, it is louder. If it is far off, then automatically it is less louder. If the listener is close to the source of the sound, he hears it quite louder. But if he is far away, the sound becomes feeble. And that is what we normally do in the phone also. So phone पे अगर हम लोग कुछ म्यूजिक सुन रहे हैं तो we put it near the ear so that others are not disturbed and you are able to hear it louder. पर दूर रखेंगे तो you are also not able to hear it properly. So that is how the distance is going to affect. If he moves further away from the source, a stage may reach when the sound becomes inaudible. Thus, closer the source, louder is the sound. This can be demonstrated by following activity. Place a clock on one end of the long table and bring your ears near the clock as shown. You will hear the ticking sound of the clock. Now move the clock on the table away from you. You will notice that the ticking sound of the clock becomes feeble and a stage comes when you will not be able to hear the sound. So otherwise you are able to hear the tuck tuck tuck, the seconds का जो sound है, you can able to hear it, but if it is far off you cannot hear it. The third thing on which the sound is going to depend upon is the surface area of vibration. I'll just note it down also so that it's easier for you to remember. So the first one was amplitude. The second one is distance of source. The third one is the surface area. Surface area of vibration. So that's what the example I gave you. The small drum के अंदर बजाते हैं तो इतना बड़ा sound नहीं आता है, but the large drum वो doom 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 आवाज आएगा, louder sound because of the vibrating surface being more, right? So a large vibration of vibrating area sends forth a greater amount of energy. So the amplitude of the vibration is large. Hence, larger the surface area of the vibrating body, louder is the sound heard. If you take two drums, one small and another big, and beat them one by one to produce vibration in them, you will notice that the sound produced by the big drum is louder than that produced by the small drum. In temples, you have noticed that the bells with the big case sound produces a louder sound than with the smaller case. So of course the bells and everything, they are going to have you if the bell is bigger, you get a louder sound. If the bell is smaller, it will get a smaller, less feeble sound. So that's why we have surface area. Depending on the surface area, the sound is going to differ. The fourth one is on the sensitivity of the listener. Now this is something which is going to be depending from person to person. And also, not only person to person, sometimes it is also subject to what is your mood. Whether you are interested in that particular sound which is coming or you're not interested. Like if you are in a party and there is a sound and then the music is being played, however loud the music may be, you will never feel it loud. You will find that अरे यार और loud कर बहुत मजा आ रहा है, okay? But suppose you are studying in the next door and there is a party going on in the next next door over there, और वो पार्टी में जो सॉन्ग्स बजे वो तुम लोग के लाइकिंग अगर नहीं है तो it is much more disturbing, okay? Because if they are liking, you may be disturbed, but we may be not liking it. I know that. But anyways, but if you are trying to concentrate and there is a sound which is given out, even if it is not that loud as much as what you were there in a party, so you will find that it will be too loud because you are disturbed. So that's why it is going to be the sensitivity of the listener. So the loudness of the sound depends on the sensitivity of the ears of the listener. So this is the sensitivity of listeners. That means the person who is going to listen to that sound. So whether he is finding it loud or not. So the loudness of the sound depends on the sensitivity of the ears of the listener. A given sound may appear to be loud to a listener, but not so loud to another listener. To a partially deaf listener, a loud sound will appear to be feeble. So if the listener is not having a proper sensitivity, is already a bit deaf, then उसके लिए तो वो और भी कम लगेगा. The energy of the sound reaching, the energy of the sound reaching a unit area of surface in each second is called as the intensity of sound. The intensity of sound can be measured, but the loudness cannot be measured. Intensity of sound does not depend on the sensitivity of the ears of the listener. However, larger the density, louder is the sound. Thus, loudness depends on intensity of sound. So, there is something which is called as the intensity of sound. Now, intensity of sound is something which can be measured. We can easily, now we always say that, okay, the sound which is produced over there by an aeroplane is this many decibel, or by a particular car is this many decibel. So the decibels which we count, okay, the decibel what we count are the energy given out by the sound. That is called as the intensity of the sound. It is a measurable quantity. So whether it is loud or not loud, okay, that is going to be cannot be measured because of the sensitivity, but the intensity of sound can definitely be measured, and it is measured in decibel. So that's why the intensity, if the intensity is more, definitely is louder, and if it is not less, then definitely the sound is feeble. So that's why we can compare the intensity with the loudness. Now, relationship between the loudness and the amplitude of wave. The loudness of the sound is directly proportional to the square of the amplitude of wave. So this over here, it is loudness is dependent to the proportional to the square of the amplitude. Okay, loudness and the amplitude are square to a square. So if the amplitude is doubled, the loudness will be 4 times. If amplitude is tripled, the loudness will be 9 times. Understood? What is the difference between the two? See, normally if it is 1:1, then if I increase the amplitude from 1 centimeter to 2 centimeters, the loudness also will become double. But अगर यहाँ पे मैंने 1 centimeter to 2 centimeter कर दिया, तो loudness will be 4 times, because double कर दिया तो 4 times means square of that thing. So 2 2s are 4. If I make it 3 times, then it will be 9 times. If I make it 4 times, it will be 16 times. So amplitude is going to be square of the. So loudness is dependent on the amplitude or square of the amplitude. So loudness of the sound is directly proportional to the square of the amplitude of the wave. It implies that on doubling the amplitude of wave, the loudness becomes 2 square 4 times. If the amplitude of wave is tripled, the loudness becomes 3 square is equal to 9 times, and so on. Thus loudness is proportional to the amplitude square, or L is equal to A is proportional to A square. Figure shows 2 waves A and B. The amplitude of wave is 2 centimeters and that of B is 3 centimeters, but both waves are of the same frequency. The ratio of the loudness B and A is 9:4. So if I having in this particular case also, what will happen? If this is 1 and this is say 3, then the loudness L1 upon L2 will be equal to 1 upon 3, the whole square is 1:9. So it's 1:9 will be the ratio of the loudness of this one and this one. The units of loudness, decibel. So the loudness is measured in decibel. Of course, that is the intensity. So the loudness of sound is measured on the special scale called as decibel scale. Note that 1 decibel is 1/10 of a bell, where bell is the unit of the level of loudness, named after the scientist Alexander Graham Bell, who invented one of the most useful devices, telephone. So loudness is measured in decibel. okay, where it is nothing but 1 upon 10 bell. Bell, which is nothing but under the name of Alexander Graham Bell. The minimum sound loudness of the sound audible at frequency 1 kHz is considered as zero level of sound in decibel. It is taken to be the reference level. When the loudness increases 10 times, the level of the sound is said to be 10 decibel. When the loudness becomes 100 times, its level is 20 decibel. When the loudness becomes 1000 times, the level is 30 decibel, and so on. So if the frequency is 1 kilohertz, that is 1000 hertz or 1000 per second, so then at that particular frequency, the loudness is considered to be as 0 decibel. Okay, that is 0 decibel. If now this is going to be 1 kilohertz, वो same है, but when the loudness is increased 10 times, that means the amplitude is increased 10 times, then the loudness is simple to be 10 decibel. If it is 100 times, it becomes 20 decibel. If it is 1000 times, it's 30 decibel. Means जितने zeros उतना time 10s, 20s, 30s होते जाएंगे. Okay. So table shows level of the sound or decibel produced by some objects. Minimum audible level 0, very much faint. Leaves rustling 10, very faint. Recording studio 20, very faint. Whispering 30, faint again. Normal conversation 50, moderate. Vacuum cleaner 60, moderate. Vehicles 80, which is loud. Diesel engine 90, very loud. Heavy hammering 110, painful. Police siren 120, again painful. And rocket takeoff 140, much painful. So the safe limit of level of the sound for hearing is from 0 to 80. You can see that 0 to 80 decibel is the safe for our ears and safe for hearing. Above that, if the value becomes above 80, it becomes a noise pollution. It becomes a noise. So the sound of the level 10 decibel to 30 decibel have soothing sensation. A constant hearing of the sound of the level above 120 decibel can cause headache and permanent damage to the ears of the listener. Such a sound is called as noise. So if there is a persistent loud sound being heard continuously by you or by any person, then that particular person will have severe effect on the ears. He may go deaf also, and he will be having a severe headache. So वो सब जब ये होता, then that particular kind of a sound is called as noise. We now move to the next characteristics, that is pitch, in the next video.